Okay, so this is the Unit 7 Worksheet A. We're going to go ahead and start by graphing in our equation. We go 5 times 2 raised to the x power. So it looks like that. And we're going to press zoom 6. So this is an exponential growth. You can see that the asymptote is 0. It looks like it's touching 0, but it's not touching 0. So the key point is usually 0, 1. But because there's a 5 out front, you're going to multiply. It's a stretch of 5. So instead of 0, 1, it's going to be 0, 5. That's going to be the main point of the whole thing. 0, 5. And you will see that on your t-table. So let's press second graph. And you'll see right there, it's 0, 5. See it right there? It's the main point. Now I think we can graph 110. Graph some points that you think you can graph. Is 220 too big? No, 220 is also a graph point that we should do. Those 3 points fit, and let's do some on this side. So let's look at the negatives. We have negative 1, 2.5. Negative 1, 2.5. It's right there. Let's see what negative 2 looks like. Negative 2, 1.25. That's good. Let's get one more. Negative 3, 0.625. So this is what it's going to look like. We're going to make sure we hit all these points here. Put an arrow there. Put an arrow there. Okay, so what is your domain? Your domain is always real numbers in these problems. Negative infinity to infinity is how far left, how far right. It's the range that's going to change problem per problem. This definitely has an asymptote of 0. You can kind of look at your t-table, second graph. Pay attention to the y's, the blue numbers. This is scientific notation for 0. This number, they are never going to hit 0. And it's never going to go negative. These are not negative numbers. These are zeros. So it never actually hits 0. So your range is how low does it go? 0 is the asymptote. And it goes up to positive infinity. So the lowest is 0, highest is infinity. And that's how you do that problem. Okay, so the next one, we're going to graph it in. The next one is 2 times parentheses 1 divided by 2 raised to the x. I think I got to do that again. Sorry about that. 2 parentheses 1 divided by 2 raised to the x. So we have this. Okay, let's put it in, and we're going to graph. Now this one should be a decay because of the 1/2 base, so it should go the other way. But notice it's still got a 0 asymptote. It still has a 0 asymptote, but it's a decay. The reason it's a decay is because the base is 1/2. The reason this one is a growth is because the base is 2. If your base is greater than 1, it's a growth. If your base is between 0 and 1, it's a decay. So we need some points. So let's look at our points. Find some points that are nice to graph. Like these are all like 0. I don't like any of these. Alright, we're getting close. Alright, so it looks like negative 3. I think negative 316 can be graphed. It's right here. Negative 2.8 can be graphed. Whoops, that's over. Negative 2.8's right here. Sorry, that's not it. Let's keep going down. Negative 1.4. 0.2. 0.2. 1.1. 2.5. 3.25. You can see it's going down towards 0. So we're going to go ahead and graph this. Your domain, how far left does it go? Negative infinity. How far right does it go? Positive infinity. Range. The lowest it goes is 0. The highest it goes is to infinity. That's your graph. So the third one. Now this is going to change a lot. We have some things happening here. We have a stretch of 3. We have a 2 right. This is going to go 2 right and 2 up. So our asymptote is going to change because of this number. The asymptote is now going to be y equals 2 because of that 2 right there. Notice we didn't have anything added to this one. That's why it was y equals 0. And this one didn't have anything added. It was y equals 0. But this one, because there's a plus 2, the asymptote I can already go ahead and write this in this graph right here. See what I'm doing right here? Because that 2 on the end, I know this has an asymptote of 2. It's not going to go any lower than that. So let's punch this in. Got 3 times 2 raised to the x minus 2. Right arrow, get out of that, plus 2. That's what it should look like. Graph. See how it looks like it's staying right above the 2 asymptote? It's still a growth. It's still a growth, but it looks like it's not hitting the 2 asymptote. So let's get a few points from our t-table. I'm liking these points down in this range right here. Let's move this up. So I'm liking like -1, 2.3. I'm liking 0, 2.75. I'm liking 1, 3.5. I'm liking 2, 5. And we got 3, 8. I've got 4, 14. Any point that you can get on this graph, you should graph. 526 is too much, so this is it. So you just go like this, connect these. So your domain, again, is -infinity to infinity. Oops. And your range is 2. That's your asymptote to positive infinity. How low does it go? 2. How high does it go? Infinity. And then this graph, you see this -2 right here? That's your asymptote. We're going to draw an asymptote here at y equals -2. This is your asymptote because this whole graph's going down 2. That's the most important number in this whole problem. So right now, I know right now without even looking at my graph that my range is -2 to infinity. It's going to go up. And I know this is -infinity to infinity without even graphing it. Get in here. Get in here. So this is 4. Shut that door, please, guys. Oh my God.
They gonna cut that off once they hear you yelling, Mr. Robert.
I'm so comfortable today. I got the jeans on.
-2. So that's, here's the problem. 4, 1/2, x minus 2. So graph. This should be a decay because the base is 1/2. But notice it goes below the x-axis this time because of that asymptote of -2. So let's do second graph and get some good points. Looks like -114 is a good one. 0.6 is a good one. 1, 2.
I got an 85 on that test, Mr. Ross.
2, 0.
Was you proud?
I was. 3, -1. I'm always proud when you do work. 4.
So what?
I'm always proud when you do work.
I know, I saw that.
And there is your graph.